Alright, problem number 1 on the study guide. If the crucible contained 1,836 grams of FeBr2, what was the weight of the iron, which is Fe in the crucible? And they tell us that the iron is 56 moles and Br, bromine, actually is 80 moles per atom. So we start off with our chart, molecular weight and actual amount in this column. Then our ingredients are iron and bromine, and we have probably iron bromide would probably be what it is called. And if we read up on what we got, first off, if we deal with the fact that we got iron bromide and we know how much the atoms are for each one, there's 1 iron, so 1 times 56 is 56. There's 2 bromine, every bromine is 80, so 2 times 80 is 160. That gets me a total of 216 moles per molecule. And then it says 1,836 grams of FeBr2, so they're telling us the amount of this, so 1836 goes here. And it says how much does the iron weigh, so we're looking for that there. So the bromine no longer is important to us. That gets me 56 over 216 is equal to x over 1836. Get our calculator out, and if I do 56 times 216, sorry, 56 times 1836, this product, that comes out to 102,816. That should equal this product. So 216x is equal to 102,816. So to get x, we simply divide both sides by 216. That number divided by 216 is 476. Okay, problem 2. Freight train took 9 hours to make the same trip. The express train made it in 5 hours. So if we take a look just at this first sentence, it's full of information. Make the same trip means distances are equal. So if I don't have to draw a picture at this point. The freight train is equal to the express train distance. And freight and express are going to be my categories. And it tells me the freight train took 9 hours and the express train took 5 hours. So they told me the exact times of each. The second sentence says find the speed of each. That implies we don't know either speed. The express train was 40 miles per hour faster than the freight train. Okay, 40 miles per hour faster, that's an addition of 40. The express train is going faster, the freight train is going slower. So I'm going to say R is the speed of the freight train, the express train is going 40 miles per hour faster. And we get our setup like that. Don't know either one, but they're both represented by the variable R. So the freight train distance is going to be 9R, the express train distance is going to be 5R plus 200. Keep in mind that we have to distribute since it's a binomial, 5 times R, 5 times 40. And again, we've already established that the distances are equal to each other, so this distance equals that distance. 9R equals 5R plus 200. We move the 5R over. That gets me 4R is equal to 200. Divide both sides by 4 gets me R is equal to 50. Unit of speed is going to be miles per hour, because that's what the unit they use there. And R is, again, if we look up here, the freight train's rate. So the rate of the freight train is 50 miles per hour. So the rate of the express train is going to be 40 more than that, so 50 plus 40 is 90 miles per hour. Always use the chart not only to organize your information to create a good equation, but also use it to interpret your answer. If you see R equals, you go back up here, see what R represents. You can see what you found, and then you can see what else you need to find based on what they're asking. So in this case, they're asking for both speeds. Make sure you give me both speeds. Number 3, solve. And we have a radical equation, and the first job of a radical equation is to get the radical isolated, this being the radical. So I'm going to start by moving the -3 over the other side. If I move the -3 over the other side, it becomes +3. 4 plus 3 is equal to 7. Next job is to get rid of the radical. We do that by squaring both sides. So once I get the radical equal to a number, I square both sides. And in doing that, squaring a square root just gets rid of the radical. So square root of x minus 2 squared is just x minus 2. 7 squared is 49. And then if x minus 2 equals 49, we add 2 to both sides. We're going to get x is equal to 51. That represents the candidate for the right answer. Now we have to actually verify that it works. We'll do that by substitution into the original problem. So the original problem is right here. Here's x. That's what's going to be replaced with 51. Everything else stays the same. So square root of minus 2 minus 3 is supposed to equal 4. And I'm going to put a 51 in place of the x. And evaluating this, 51 minus 2 is 49. 49 square root is 7. 7 minus 3 equals 4 is obviously true, so that's a good answer. All right. Typically on tests, I'm going to make them work. So I still want you to verify, just in case I make one not work, but just know that empty set is more than likely not going to be the right answer to the question. So expect the answer you get to work. If it doesn't work, check your work to make sure that you did everything correctly. Number 4, square root of x squared minus 3x plus 3 plus 1 equals x. Same family of problems, a little bit more challenging. The 1 moves to the other side, just like the last problem, to get the radical isolated. So we're going to get the square root of x squared minus 3x plus 3. Over here we're going to get x, move that over, minus 1. At this point, same issue. We have radical equals stuff, so I'm going to square both sides. If I square the left-hand side, it just gets rid of the radical, so I get x squared minus 3x plus 3. If I square the right-hand side, I have a binomial squared, so I got to create a trinomial. It's created by these two objects. We're going to square the first object, we're going to square the last object. The squares are always positive, and then I double the product. Negative 1x doubled is negative 2x. So the minus sign does have an effect on the middle term. These outside terms are always positive. And if you take a look, what happens here, and it should happen on the test also, I've got an x squared on the left and an x squared on the right. If I move one to the other side and subtract, it's going to cancel those. So those just cancel. We're left with a pretty basic linear equation. I'm going to move the 3x over to the right-hand side, move the 1 to the left-hand side, or vice versa, doesn't matter, just get them separated. 3 minus 1 is 2, and negative 2x plus 3x is equal to 1x. Again, that represents my candidate for the right answer. Now I have to verify that it actually works. So I go back to the original problem as is. I'm going to change all the x's into the number 2. Right, so x squared is going to be 2 squared, which is 4. Minus 3x is going to be minus 3 times 2, which is minus 6. Plus 3 is supposed to equal x, which is 2. So again, that's all you have to do is you replace all the x's with the number 2. I went ahead and squared it. 2 squared is 4, and multiplied by negative 3. Negative 3 times 2 is negative 6. Do that to the extent you're comfortable doing that. 4 minus 6 is negative 2 plus 3 is 1. Square root of 1 is 1. 1 plus 1 equals 2, obviously correct, so 2 is the right answer. Again, on these two problems, I would expect the answers to work. So again, if they don't work, chances are you messed up over there. The most common mistake here is forgetting about this minus 2x. Be ready to watch for that. Number 5, use unit multipliers to convert 80 miles per hour. So when you see 80 miles per hour, the per puts the hours on the bottom, 80 miles goes on top, and our job is to convert miles to feet, and we're supposed to convert hours to seconds. And the blue highlighted conversion has no bearing on the yellow and vice versa. So I can change miles into feet first, hours into seconds second, or vice versa. It doesn't matter. But just know that that's where we need to go. So I'm going from miles to feet. We'll do that first. I know that miles is going to go in the denominator, feet in the numerator. In order to cancel the unit of miles, 1 mile is equal to 5,280 feet. Mile cancels mile, and now I have feet. So now feet per hour, I want feet per second. So at this point I'm going to change from hours into seconds. And again, the position of things is based on where they are. Hours is currently in the denominator, so I need hours in the numerator to cancel. I'm going to change that to minutes. And the fact about hours and minutes is every 1 hour equals 60 minutes. Hour cancels hour, and we're down to feet per minute. And then I want minutes to go away, change to seconds. Minutes is currently positioned in the denominator. I'm going to put 1 in the numerator to cancel. I'm going to put seconds in the denominator, and 1 minute equals 60 seconds. Minute cancels minute, and we're left with all this, which leaves me 80 times 5,280 divided by 60 divided by 60 equals. That's what I'm going to take my calculator. Every top number is a multiplication, every bottom number is a division when we enter in our calculator. So I do 80 times 5,280 divided by 60 divided by 60 equals. Comes out to 117.33 feet per second. I'd be fine with FPS also if you wish. But 117.33 doesn't have to come out to a nice pretty integer. Decimals are fine. A couple decimal places when it does that. Number 6, simplify. We have a radical 1 being multiplied by radical 2. And I am going to have this raised dot to make sure that it is very obvious that that 5 does not belong to that y. That y is to the 5th all by itself. And our first job when we see radicals being multiplied together is to get them out of the radical form, get them into fractional power form. The index of this is a square root, so it's understood 2 there. And I'm going to take m, and the power divided by the root gets me the fractional power. So 3 halves y to the 5 halves. For the one outlined in red there, the index is 5, the powers are 2 and 3, so we make fractional powers again. Power divided by root is going to be 2 over 5, and y to the 3 over 5. So that's priority 1. Get all the radicals gone, get them into fractional power form. Then you're going to multiply the same letters by adding the powers of those letters. So for m, I'm going to be adding 3 halves to 2 fifths. And for y, I'm going to be adding 5 halves plus 3 fifths. In each case, the common denominator is 10. Adding fractions requires a common denominator. So if I go ahead and make that common denominator happen for m, 2 times 5, so 3 times 5. 5 times 2, so 2 times 2. Do the same thing for y. 2 times 5, so 5 times 5. 5 times 2, so 3 times 2. And just like that, we get everything over 10. So we end up with m to the 17 tenths, y to the 31 tenths. And that's the type of base I'm looking for on that problem. Okay, so create the fractional powers, add the powers of the common letters, get a common denominator in order to actually add them together to get your final answer in the best form possible. Number 7, similar type of problem, different technique. This time you can see the square root goes all the way over everything. So when that happens, our first priority is to deal with the stuff inside. So I'm going to deal with all this stuff inside. And my goal is to get both of these numbers to be the same number raised to some power. 2 is prime, I can't make that any better. 32, if I go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 is 2 to the 5th power. And this 2 is to the 1st, and it's being the 5th root of it. So 2 to the 1/5 power, we create that fractional power out of that. So what's in red is equivalent to what's up here circled in red. But now we have 2 to a power times 2 to a power, so now we can legally multiply those 2's by adding the powers. So 2 stays 2, it doesn't change. The base stays what it is. We're going to add 5 to 1/5. 5 is the same as 25 fifths, common denominator exists, so 26 over 5 is what we get out of that. And once we get a number raised to a power inside a radical, now this index is going to multiply by this denominator to get our final answer. So we're going to get 2 to the 26 over 2 times 5, which is 10. And that's what you're looking to do there. So again, deal with what's underneath, get them both the same number to a power, multiply those 2's by rewriting 2, in this case, if it's 3, 3, whatever this number is, they should be the same. That's what is written here. These two things add together to get the power, and then just multiply the power denominator times the index to get the new denominator. These are already set in stone at that point. Number 8, 2 to the 5 square root of 5 sevenths plus 4 square root of 7 fifths plus the square root of 140. The first two we have fractions, so I'm going to do 2 times the square root of 5 over the square root of 7. I'm going to rewrite that. I'll leave myself a little bit of space. Then I'm going to rewrite this as plus 4 times the square root of 7 over the square root of 5. Leave a little bit of space. I'm going to take this and leave a little bit of space there and there. And I'm going to put the square root of 140, which if I did a factor tree, 14 times 10 is 140. 14 is 2 times 7. 10 is 2 times 5. So 2 times 2 times 5 times 7. Break it down to all prime numbers. So first off, with fractions, split them apart. Fraction of square root of top, square root of bottom, square root of top, square root of bottom. Whole numbers go on the top with the numerators. And the other number here, whatever this is, you're going to break it down. 140 is 14 times 10, all prime numbers. And then fixing each thing is a matter of dealing with what's wrong. So in this case, what's wrong is the square root of 7 on the bottom. Multiplying top and bottom by the square root of 7 is going to fix that. What's wrong here is the square root of 5 on the bottom. Multiplying top and bottom by the square root of 5 is going to fix that. And what's wrong here is there's too many 2's in there. A pair of 2's gets come out as a 2. So in that step, that's what you're doing. The fractions get fixed and the perfect square factors get pulled out of that radical. And when we simplify what we're looking at this point, on top, 2 is outside, square root of 5 and 7 are both inside. On the bottom, square root of 7 times itself makes 7. Here on top, 4 is outside, nothing happens to it. 7 times 5 is 35 on the inside. Square root of 5 and square root of 5 make 5 on the bottom. This last one, 2 got outside and 35 stayed inside. I'm going to put that over 1 to create a fraction look to it. At this point, all three of those radicals should be exactly the same. If they aren't, the bigger one can be reduced like this to make the smaller ones. And at this point, we want to add the fractions by getting a common denominator. Let me just say this for about the 1000th time. You cannot make fractions disappear because you don't want them there. All right? There's no equal sign in this problem. Fractions have to be there. Make sure fractions are there. 35 is the common denominator. And in each case, I simply have to ask myself, what do I need to do to make that common denominator happen? So times 5 on this one, times 5 on top, that gives me 10 times the square root of 35. The second one, times 7 makes 35, times 7 on top is a consequence, 28 times the square root of 35. The final one, we have 1 has to be multiplied by 35, so 2 has to be multiplied by 35. That makes 70 times the square root of 35. And once I get everything, something times the square root of 35 over 35, then I simply have to add the top stuff together. It's all pluses, plus, 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 so everything's being added. 10 plus 28 is 38, plus 70 is 108. So 108 times the square root of 35 over 35 is your final answer to that. The only thing I would try to do beyond that would see if there's a common factor, like if this reduced at all, but 108 over 35. If you tried 108 divided by 7, doesn't come out evenly, and 108 divided by 5 doesn't either. Those are the only two numbers that go into 35. So ignore the radical, just look at that fraction to see if it reduces. I'm not going to count off for not reducing that fraction though. Number 9, find side B. Okay, side B is over here. They give us this angle, this acute angle, 54 degrees. If I look and identify the opposite side going across the triangle from the angle, this is the right angle, go across that, that's the hypotenuse. That makes B the adjacent side in this case. And looking at the two sides I'm going to work with, the hypotenuse and the adjacent side, and remembering SOHCAHTOA, I'm going to work with the adjacent and the hypotenuse. I want to know the adjacent, I do know the hypotenuse. That tells me cosine is going to be the useful trig function that will help me in this problem. So if I take the CAH of SOHCAHTOA and write a good trig equation from that, it's C is for cosine of the angle we're working with equals the adjacent side, which is B, over the hypotenuse, which is 8. Always put your trig function over 1. All right, so you created this nice little proportion. But again, writing a good trig function, C is for cosine of the angle 54, that's the angle we chose to work with, over 1 equals adjacent over hypotenuse. And then my calculator evaluates cosine of 54 for me. Do ensure that your calculator is set to degrees, not radians. The cosine of 54 is 0.5878. So that gets me a simple proportion now. 0.5878 over 1 equals b over 8. So this product, 1 times b, equals this product, which is going to be the answer. And if I get the answer, it's going to be 0.5878 times 8. Comes out to 4.70. 4 decimal places in your work, 2 decimal places in a final answer. That's all they're asking me for on that problem, so that's it. So b is equal to 4.70. Number 10, find angle A. So once again, looking at the angle we want to find, which is this one, and I identify for angle A the opposite side, which is down here. The hypotenuse is over here, and the adjacent side is right there. Once again, the two sides I'm going to work with are the adjacent and the hypotenuse. No guarantees on the test that you'll use cosine both times, but in this case it looks like cosine is the best. Again, if we consider SOHCAHTOA, once you've established the side you're going to work with, that establishes which one of the three trig ratios is going to be helpful. Cosine, C for cosine, of the angle, which is A, is equal to the adjacent side over the hypotenuse. Now the last problem we knew the angle, so we have the ability to type in cosine of angle equals. We got a numerical value. This time we don't know the angle. When you don't know the angle itself is going to be the inverse trig function of the number. So whatever trig function that is, if that's tangent, do tan -1. Sine, sine -1. This is cosine, so cosine -1 of whatever that number is. That's how you find the angle if you know what the cosine value is. On the calculator, that's above cosine, so hit second, cosine, see the cosine -1, type in 7 divided by 12, and hit enter, and we get 54.31 degrees. So on the test, remember SOHCAHTOA, identify your three sides. Again, in this problem, the two sides you know establishes which trig function is helpful. In this problem back here, the side you want to know and the side you do know establish which trig function is helpful in finding what you're looking for. Number 11, divide 4x cubed minus 5 by x minus 2. If I use the synthetic division technique, we're divided by x minus 2, so I put a positive 2 there because 2 minus 2 makes 0. And then the coefficients of this are going to be 4x cubed, 0x squared, 0x, and -5. Positive 4, x squared and x to the first are both missing, negative belongs to the 5. And once I've got these set up, created, I put this bar here with some space to write numbers. I'll bring the first number straight down. And then from this point forward, it's a multiply to get the next number, add to get the next number. So 2 times 4 is 8, 0 plus 8 is 8. 2 times 8 is 16, 0 plus 16 is 16. 2 times 16 is 32. -5 plus 32 makes positive 27. Subtraction there because the signs are different. Positive because 32 is bigger. The number at the end is the remainder. Everything else is the answer. Constant, x to the first, x to the second. So I'm going to write 4x to the second plus 8x to the first plus 16 plus 27 over x minus 2. These pluses are necessary. If you just put x squared, x, 16, and just like that, that's no good. All right, so again, once you get this answer here, once you get this right here, positive 4x squared plus 8x plus 16 plus 27. If this was -16, you put -16, that's -27, you put -27 over x minus 2. The signs that happen here are going to be the same signs that you put in your final answer. Number 12, find the distance between the points. Find the distance. Distance is a number. It's not an equation. It's not y equals anything. It's just a number. Distance is equal to the square root of a square plus a square. And what goes here is the distance between those two. So if I'm at 4 and I go to -2, I've traveled 6 spaces. And if you count it off, 4 to 3 is 1 to 2 to 0. Oh, sorry, 4 to 3 to 2 to 1 to 0 to -1 to -2. Okay, that's counting on your fingers. You can do it that way. Or you just subtract 4 minus -2 is 4 plus 2, which is 6. If I'm looking for this number, I'm going from here to here. If I'm at -6 and go to 2, I've got to go 6 spaces to get to 0, 2 more to get to 2, so that's a total of 8 spaces. All right, so distance is the square root of 6 squared plus 8 squared. Then we just evaluate. 6 squared is 36, 8 squared is 64, 36 and 64 make 100, and the square root of 100 is 10. Okay. Once you evaluate the square root of 100 as 10, it's not a square root anymore. You've evaluated it. So just throw the square root out. That equals 10 exactly. Came out to a nice pretty answer on the study guide. If it comes out the square root of 37, leave it. If it's the square root of a nice pretty number like 36 or 64 or 25 or anything like that, go ahead and take the square root. Number 13, simplify. We have a division of rational expressions, and first thing I'm going to do is rewrite this problem as a multiplication. And if you look at the two objects circled in green and purple, they both have an x cubed in them, so I'm going to take an x out as I rewrite this thing. So the problem itself, I'm going to change from a division to a multiplication. The first fraction stays exactly as it is, so x squared minus 2x minus 3 is going to remain on top. On the bottom, I'm going to take the common factor of x out, leaving me with x squared minus 3x minus 4 on the bottom. The second fraction is going to invert, it's going to reciprocate, so this is going to go on top, and I'm going to take the x out, so x is coming out, x squared minus 2x minus 8 is left over. This is going to go to the bottom, x squared plus 2x minus 15. For me personally, that's what my first step would look like in this problem. That's what I personally do. If I have x cubes, I take those x's out as I change it to a multiplication problem. So then what I'm left with is a quadratic, a quadratic, a quadratic, a quadratic, each of those factors the same way, and it's pretty straightforward from here. So negative 3 times 1 is negative 3, negative 3 plus 1 is negative 2. For the green one, x is already out. Negative 4 times positive 1 makes negative 4. Negative 4 plus 1 is negative 3. For the purple one, negative 4 times positive 2. Better to write the correct number there. Negative 4 times positive 2 makes negative 8. Negative 4 plus positive 2 makes negative 2. For the red one, positive 5 and negative 3. And multiplies make negative 15, 5 minus 3 is positive 2. So we get factor everything as much as we possibly can, and then we cancel common factors. This x is exactly the same as that x, they cancel. This x minus 4 matches that x minus 4, x plus 1 matches x plus 1, x minus 3 matches x minus 3. The leftover pieces are x plus 2 on top, x plus 5 on the bottom. And it will be like that on the test. Everything will cancel except for one thing on top and bottom, so if it doesn't, you messed up. Check your factoring, check to make sure you've inverted this fraction, that kind of stuff. Number 14, notice find the equation of the line. Now this time it wants the equation of the line. So go back to number 12, find the distance. This one says find the equation of the line. Notice the points are exactly the same 2 points, but they're asking us to do different things. So a lot of you are missing these because you're doing the wrong thing. It says find the distance, you find the equation. It says find the equation, you find the distance. Find the equation of the line is y equals mx plus b. Our job is to find the slope and the y-intercept. Slope, when we get 2 points, is the change in y, that's y2 minus y1, over the change in x, which is x2 minus x1. Right? It's very important with slope that we go the same direction. So I did this point minus that point on top. I have to do this point minus that point on the bottom. Y is on top, x is on bottom. If I do the slope formula correctly here, minus minus is the same as plus. That gets me 8 on top. Minus 2 minus 4 is minus 6, which gets me a negative 4/3 slope. So negative 4/3 is my slope. All I have to do now is find the y-intercept. And to find the y-intercept, I'm going to take one of these 2 points. Doesn't matter which one. I'm going to change x and y into the point values from the x and y point that I'm picking. So if I do those substitutions, I'm going to put negative 6 in place of y equals, put negative 4/3 in place of m, putting 4 in place of x, and I'm putting b where b is because I don't know what it is yet. If I look at the right hand side, I'm multiplying an integer times a fraction. The integer's denominator, the denominator and integer don't reduce, so all I can do is multiply the top. So negative 16 thirds plus b. This is thirds, so I need this to be thirds. Currently it's first, so times 3 makes negative 18 thirds. I move the 16 thirds over. Negative 2 thirds equals b. I have a slope, I have a y-intercept, I have an answer. Y equals negative 4 thirds x minus 2 thirds. So again, same 2 points for 12 and 14. One says find the equation line, one says find the slope. Make sure you do what you're supposed to do in each of those problems. Number 15, solve. We got a rational equation and we have a common denominator of 20. So multiply by 20. Before I do that, what we have been doing in class, let me just do this real quick. This fraction splits apart into 3x over 4 minus 5 over 4, where the other two fractions are already out, so minus x over 5 equals 2/5. There's no sign in front of that fraction, so nothing happens weird with that, just you get what you get. And then, at this point, the common denominator being 20, we're going to multiply 20 times the first, 20 times the second, 20 times the third, 20 times the fourth. In each case, multiplying by 20 is first division, then multiplication. So 20 divided by 4 is 5, times 3x is 15x. 20 divided by 4 is 5, times negative 5 is negative 25. 20 divided by 5 is 4, times negative x is negative 4x. And 20 divided by 5 is 4, times 2 is 8. So split the fraction apart, multiply everything by a common denominator, all the fractions disappear. This is legal in this problem because there's an equal sign. Again, fractions, you don't get to eliminate fractions all the time. If there's an equal sign, it's legal to do it. Go ahead. At this point, I'm going to solve. I'm going to move this negative 25 to the other side. It becomes positive 25. 15x minus 4x is 11x. 8 plus 25 is 33. Divide both sides by 11. Get rid of the number in front of x. X equals 3 is the right answer.